All right, hi everyone. I'm going to show you the steps to doing an ANOVA and SPSS. I'm using the Practice SPSS database, so don't confuse it with whichever database you're using. So to start with, you're going to need to go to Data, Split File, and you're going to want to compare groups based on your independent variable. And remember, for an ANOVA, the independent variable must be categorical, and it must have more than 2 categories. So then you'll tell it OK, and your output will pop up and tell you that the file has been split. So make sure it does that before you move on. Then you'll go to Analyze, Descriptive Statistics, and Frequencies. In this box, you'll want to make sure that you uncheck the frequency tables because that'll give you a really long table that you don't need. Then you'll go to Statistics, and in this box, you'll check skewness and kurtosis and tell it to continue, and OK. So you will use this table to fill out this skewness and kurtosis calculator. So I've already gone in and done that. I'll want you to see that you actually don't use this first box here. This has all of them put together. You'll want to look at it group by group. Okay, so this first variable here is my first group, so you'll see negative 0.08 is here, 0.136, then 0.677 and 0.271. Once I got all of the variables in here, I found that only this one was outside the range of normality, -3 to +3, and only by the tiniest bit. So we're going to go ahead and say these data are normally distributed. When you're doing this, you want at least half of them to be within the range of normality, and then you can say it's normally distributed. That's kind of a general rule. Okay, so after you've calculated the skewness and kurtosis, you'll go back to Data, Split File, and tell it to analyze all cases, and tell it OK. And you'll want to make sure it says Split File Off. All right, so now you're going to go back to Analyze. You're going to go to General Linear Model, and tell it Univariate. You're going to put the dependent variable in this box and the independent variable in this box. As a reminder, the dependent variable must be continuous or interval in order for ANOVA to work. Okay? You'll want to go to Options, tell it Recode Age is going to go here, and then Descriptive Statistics and Estimates of Effect Size. Tell it Continue, and go to Post Hoc. You'll want your independent variable to go in this box until it's Chiffé, and continue, and then OK. So there are a couple of boxes that you're going to need to look at on in this output. The first one is the test of between subjects effect. This is the ANOVA box. I'm going to show you how to use that in a second. And the next one is this recode, this post hoc test box, and then it'll tell you what that independent variable was here. So you'll need both of those boxes. So the first one that you'll need is your ANOVA box. So I copied this one over here so I can show you what you need to use here. So the numerical sentence, this is the example, and then I've actually highlighted where each number comes from. So you need the degrees of freedom between, which is right here. You can see I put 3 in here. The degrees of freedom within, which is here. Notice that this is your independent variable name, so yours won't say Recode Age. Yours will say whatever your independent variable is. So you're using this third line down. The F value comes from the F column, and then the P value comes from the P column. Reminder, if this says 0.00, then we'll actually say less than 0.001. So that's going to be your numerical sentence that you'll use when you write this up. The next thing that you'll look at will be your post hoc table, and this is going to tell you where the differences actually occur between the different groups. So you're going to look at this table and you're looking for statistical significance to determine where the differences are between your groups. So you can see each one of these lines here, or these boxes here, compare the different groups. So this is comparing ages 6, 7, and 8. This is group 1 to group 2, 3, and 4. So you can see group 1 compared to group 2, there's no statistical significance. But group 1 compared to group 3 and group 4, there is statistical significance. So when you're interpreting this, you could say statistically significant differences were apparent between group and whatever this group is. For me, that's ages 6, 7, and 8, and ages 11 and 12, and ages 13, 14, 15, and 16. This sort of makes sense because these two ages are fairly close to each other. So there's not a difference between the two groups that have ages similar, but these groups that have ages further apart have a difference. As you move down this, in the boxes, you need fewer and fewer lines. So we've already compared ages 6, 7, and 8 to ages 9 and 10 in this box. So you don't need it in this line. This first line here you won't need, because you see this is the same value here. But we haven't yet compared ages 9 and 10 to ages 11 and 12, 13, 14, 15. So this is comparing group 2 to group 3 and group 4. And you can see there is a statistically significant difference between both of these comparisons. As you get down to this next box, you won't need to compare group 1 to group 3 and group 2 to group 3 because you've already done that up here. So this is comparing group 3 to group 4, and there is not a statistically significant difference. And in this very bottom box, you don't need any of those because you've already compared everything to group 4. So that's how you would be able to describe the differences found between the groups. So you actually have a statistically significant difference between group 1 and group 3 and group 4, and you have a statistically significant difference between group 2 and group 3 and group 2 and group 4. So you would go through your post hoc table here and identify the differences you found between your groups, and you'll be able to describe that in your narrative. All right, that's it. That is how you run an ANOVA. So of course, as always, if you have questions, you can email me. Bye.